So in this video, we're going to take a look at how we can use our original definition of the derivative using the limit and kind of derive some rules for taking derivatives from there by looking at some patterns. So suppose you started plugging some polynomials in here, like let's see, y equals x. So you plugged that into this function, you would get that y prime equals 1. Suppose you got y equals x squared. You plug that into your formula up here, you would get that y prime is equal to 2x. If you have y equals x cubed, you will get that y prime is equal to 3x squared. And if you continue with the same pattern, you'll get that if y equals x to the fourth, your derivative is going to be 4x cubed. Similarly, if you take a second derivative of some of these, say you took y double prime over here, following the same pattern, you would get y equals 2. Over here, y double prime would equal 6x. And over here, y double prime would equal 12x squared. So, what does this tell us? Let's go ahead and follow the same pattern that we have here, and let's just apply, write down a general rule. This is what we call power rule. So, power rule is going to be where we have some polynomial x to the n. If y equals x to the n, then it follows that y prime is equal to n times x to the n minus 1. So this is power rule. Now, in this video, we're going to cover a couple more rules, and then in the next video, we'll go over product and quotient rules. So in this video, this is the most important one right here. You'll need to memorize that. This power rule is a very important rule for taking derivatives. We can use this to take the derivatives of virtually any polynomial. So let's say we had y equals 4x cubed minus a third x squared plus 1. We could say that y prime is equal to n times the constant out here, which is 4 times 3, which is 12. So we'll go ahead and just write that. So we have 12x to the n minus 1. 3 minus 1 is 2. So we have 12x squared minus 2 times a third. So that's 2/3 x to the first power plus 1, which is times x to the 0th, technically. So we have 0 times 1, which is 0. So plus 0. The derivative of a constant is 0. Now, our other rules are going to be these. We have the constant multiplication rule. So you see back here when I took the derivative, I left that constant out front and then multiplied the 3 down. So anytime we have a constant inside of our derivative, we can say that we'll use this notation. We'll use the d over dx. This is another way of denoting that we're taking a derivative of a function. So we have a constant outside of our function, such as 4. So y equals 4 times x cubed. Anytime we have a constant outside of our function, this is the same thing as saying k multiplied by that derivative. Okay, so as an example, we can say y equals 3x cubed. We can go ahead and pull that 3 out and say is 3 times x cubed prime. which is equal to 3 times 3x squared, which would give us 9x squared. Alright then. Another, the last rule we'll cover in this one is basically when we have the derivative of an addition of functions. So say we wanted to take the derivative of the following. We have f of x plus g of x. Well, this is the same thing as f prime of x plus g prime of x. And it's that simple. So the derivative of the sum of the two is equal to the sum of the derivatives. In the next video, we'll go over product and quotient rules. But in this video, the 3 rules that we need to remember are power rule. We can pull out a constant out of any derivative and multiply it independently, or leave it in there and take the derivative. It doesn't matter. We can take it out if we need to. And finally, the derivative of the sums is equal to the sum of the derivatives.